Okay, so here is our second packet for our first unit. And this packet focuses on functions. But before we can study functions, we have to understand what a relation is. So a relation is nothing more than a set of ordered pairs. Okay? And as you're going to see, there are many different ways we can represent a relation. But for example, a set of ordered pairs would be something like 0, 1, 1, 3, 2, 6. Okay. Whenever you have a bracket like this, that is set notation, just so you know. Now, sometimes our relations, when you graph them, they make certain shapes. It could be a line, a U, a circle, all sorts of things. And other times, there's really no rhyme or reason to them. But we do need to review the coordinate plane. Okay, so an ordered pair is simply, or are simply, the coordinates of a point written as x comma y. Okay, it might be hard to see, but whenever we graph on the coordinate plane, we have an x-axis that's horizontal and the y-axis, which is vertical. A coordinate pair means that a point is always given in order. The x value always comes first. Now, the x value is your horizontal value. Whatever that first number is, that is how many left or right you are going to move. And your y coordinate is your vertical value. So whatever that is, you're going to move up or down. So for example, let's say I have the point A, which is 2, 5. So on my coordinate plane, first of all, we always start here. This point right here is the origin, and it has coordinates 0, 0. So from the origin, we would go 2 to the right and then 5 up. And that would be point A. Okay. Let's say we had point B, which is -1, -7. So this would mean left 1 and then down 7. Right here. What if we had something like C, which is 0, 2? Now, here's where it's really important to remember what a coordinate pair is. The 0 is your x value. That means you are not moving left or right any way. You're staying where you are. The 2 is your y value, so that means we're moving up 2. Okay? Now, let's flip this for a minute. And let's say I asked for the coordinates of this point right here. We'll call it D. Think about what those coordinates would be. So the first thing you want to ask yourself is, how many did we move to the left or right? And we moved 1, 2, 3, 4, 5, 6. 6 to the left, so -6. Then how many did we move up or down? Well, we didn't move any, so 0. Okay, now we get into the representation of a function, or I'm sorry, a relation. It can be represented as an ordered pair, set of ordered pairs, as a graph, with a table, with a mapping, or as an equation. So we're going to go over each of these right now. So first we have a relation that is given to us as a set of ordered pairs. we see the bracket. It says express the following relation as a table, a graph, and a mapping, then determine the domain and range. So we'll get to that in a moment. All right, so we already have it as a set. As a table, we would simply list each of the x values. So we have -1, 1, 2, and 3, and then their corresponding y values. So -1, 1, 1, and 2. Then as a graph, we would plot the points. So -1, -1, 1, 1, 2, 1, and 3, 2. And last, we have what is called a mapping. So a mapping is usually like two ovals or sometimes two rectangles, some sort of shape. The first oval always consists of your x values. The second oval always consists of your y values. Now, what's a little different about a mapping from, say, a table is whereas in a table you may see repeating values, whether it be the x or the y, you won't see that in a mapping. So for our x values, we again have -1, 1, 2, and 3. But for our y values, we're just going to put -1, 1, and 2. We're not going to repeat the 1. So then how would we know, which numbers go together? Well, this is where we do our mapping. We draw arrows. So -1 goes to -1, 1 goes to 1, but so does 2. And then 3 goes to 2. And later in the unit, we'll talk about the significance of the arrows. And the last terminology is domain and range. The domain is simply all of your x values. And typically we will list them as a set as well. Those are my cats chasing each other. So our x values, again, -1, 1, 2, 3. And I should mention, technically the order doesn't matter. I like just putting them in, order from least to greatest. And our range are our y values. So we would have the set -1, 1, 2. Again, we're not repeating the 1, even though it happens twice. Okay, so let's do a couple examples. And actually, I'm going to do, well, you can pause at any time. So I will go through each of them. Okay, so first we are expressing our relation in a table. So this time I'm going to do the x with the y. So 0, 4, 4, -4, -2, 3, 4, 0. Then a graph, 0, 4, up 4, 4, -4 over here, -2, 3, and 4, 0. And then a mapping. So we have 0, 4, -2. I'm not repeating the 4. And then we have 4, -4, 3, 0. We draw our arrows. So 0 goes to 4, 4 goes to -4, -2 goes to 3, but then 4 goes to 0 again. And then you get your domain from your mapping. Well, your domain and your range. See, I went out of order there. It doesn't matter. Okay. So number 2 might be a good one for you to pause the video and try on your own. Okay, so this one was a little unusual because our range consisted of one number, 1. Every single x value had a y value of 1. Okay, when we talk about coordinate pairs and graphing on the coordinate plane, we also have to talk about independent versus dependent variables. Now, this is something that has probably come up in your science classes. So, in a relation, the value of the variable that determines the output is called the independent variable. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. The domain contains, and this is really important, the domain contains the values of the independent variable. The range contains the values of the dependent variable. Now, just to go back up for a second to the sentences, basically, usually, especially if our relation is representing some sort of real world situation, the independent variable is the thing that nothing controls. So oftentimes it's going to be time. You can't control time. And the dependent variable, again, is literally the thing that is dependent on the first amount. You can't know the output until you know the input or the independent variable. So identify the independent excuse me, and dependent variables for each relation. And you will have to do this in the additional practice. So the more hours Maribel works at her job, the larger her paycheck becomes. So let's think about what is independent and what is dependent. And it doesn't matter what order you think of this is. Sometimes it's easier to think of the dependent. Well, her paycheck depends on how many hours that she works. So her hours are the independent. Her paycheck is the dependent. Okay. Number 2, increasing the price of an item decreases the amount of people willing to buy it. So if you think about it, as far as independent and dependent, the number of people purchasing the item depends on the price. So the price is your independent. The number of people purchasing is your dependent. The dance committee is selling tickets to the fall ball. The more tickets they sell, the greater amount of money they can spend. Okay. So, number of tickets is our independent. The amount of money is dependent. Okay. I'm going to pause for the next two. You should try them on your own. And then if you have any questions, we can always go over that in class. Okay, so here are 4 and 5. And our last problem, the graph, or it says, describe what is happening in the graph of the relation. The graph represents the value of a rare baseball card. So what seems to be happening? Well, as time is getting larger, right, that would be here, what's happening to the value of the card? That is also heading up. So you could say something like the value of the card increases over time. Okay, something along those lines. All right, So in class tomorrow, you are going to work on the additional practice for this set that is on Go Formative.